So, let's see if we can remember this, okay? Sine, if you remember, it's the mixed up one. Yeah, it's mixed up. So it's got sines and coses lumped together. So, how does it start? Sine A plus B. We try and get the angles in order, right? So we're going to have our A's first and then our B's first, okay? So sine A, what? Sine A, what follows? Cos B, thank you. Plus, and then they switch around, right? So if we take the angles in the same order, you'll get cos A sine B, okay? Now before we leave off this, okay, this is what we'd call a sum expansion, as in, you know, when you add things up, okay? Because sine A plus B, right? You can see from here, and if you think back to our work on odd and even functions, right? It's very easy, once you know this expansion, to work out the difference expansion. So instead of A plus B, what if we had sine A minus B, if that was the only difference, okay? So what I'm going to do is consider this as just a version of the previous line. Okay? So it's a difference, but I'm going to consider it like a sum. So I'll take sine of A plus, and it's a little bit like, do you remember when we were doing addition and subtraction of graphs, you know, adding and subtracting ordinates, okay? So this is plus negative B. You see I haven't really done anything here, yeah? Now if that's the case, everywhere I've got a B here, in my previous expansion, I'll put a negative B, okay? So here we go. A's are the same, sine A. Instead of cos B, I'll have cos of negative B, okay? And then, in the same way, along here I'll have sine of negative B instead of sine B. Okay? Now again, remember, odd and even functions, right? Cos. Cos is an even function. That's what it looks like. Okay? So you got your reflection across the axis. Even functions mean f of x is f of, remember? Minus x. Good. So here, this thing here, cos of negative B, that might be over here, right? Should be exactly the same as cos B, right? There's a reflection there. So I've got sine A cos B out the front. Okay? Sine, on the other hand, is not even, it's odd. Okay? So it works like this, except in reverse. Okay? You've got your negative out the front. So therefore, this negative here, I'm going to take out and put in the middle. Okay? So I'm going to have minus cos A sine B. You see that? Okay? So all I've done, if you like, changing this plus, right? That plus makes a plus over there. So this minus makes a minus over there. Okay? So, same identity, just slight adjustments. Okay, we can do the same kind of thing with cos. So, let's see if we can remember. We said that sine was mixed up, you've got your sines and coses together, but cos keeps your functions the same, right? So because it's a cos expansion, we start with cos. Cos A, cos B. And cos was reversed. After you finished your geometric exercise, you notice you had a negative here, right? A minus. Then you've got your sines. Okay, so you remember that. Now, therefore, if we do the same thing here, if I have A minus B, which is plus negative B, okay, what would that mean? The A's are the same, and the B's change. Okay? So therefore, this cos of negative B will just be cos B, and this sine of negative B will be negative sine B. So it's going to cancel that negative sign, right? So cos of A minus B is equal to cos A, cos B, because we remember that was even, right? Plus sine A, sine B. Okay, so again, same idea of swapping, but this time it's upside down, because the cos, its plus, turns into a minus, right? And therefore its minus turns into a plus. Okay? So as a result, sometimes you'll see this all condensed. Get another colour. Because they're so similar, these formula, these expansions, right? Sometimes you'll see it written in this way. Sine of A plus or minus B. Okay, because they're trying to collapse things together. The first term will always be sine A cos B. Right? And then when you have in the middle, depends on what you had at the start in the middle here, right? And then you'll have cos A sine B. Okay, in exactly the same way, you'll get your cos of A plus or minus B. But because it's reversed here, you'll get the plus or minus sign, but it will be upside down. Does that make sense? Because this plus goes with this minus, as opposed to this plus going with this plus. Okay? So they're not confused or have vertigo or anything. They're actually trying to pair those up intentionally. Okay. All right. Now those are the sine and the cos ones. Okay. Now if you did your geometric exercise for the reverse side of that sheet, you'll have the tan ones already. But actually, you can work out the tan ones from here, because tan is just a relationship between sine and cos, right? So for instance, I've got some space, so I'll keep going down here. Tan A plus B, if I wanted to work that out, okay? Well, tan is sine over cos, right? So it'll be sine of the same angle on cos of the same angle, okay? Now, when you think, ooh, I know what these are both equal to, right? They're up here, okay? The first thing you do is you just sub it in, okay? So this is what it'll look like. But as you start to write it out, you think, oh no, this is not getting better. It is getting worse. Because I don't know about you, I would say that looks simpler than this, right? However, we can keep on going a little bit here with these four terms, okay? I can divide through all of them by one thing that'll make it a lot simpler. Okay. The question is, what's the one thing? Now, if you have done if you've done the reverse side, you can sort of guess what I might divide by to make it all nice and neat. I'll take the guesswork out for you because it'll be faster. When you have a look at these four terms, okay. I want to divide through. Here's a way that I might make this simpler. That'll turn all these sines and causes into different kinds of tans. Okay? Different kinds of tans. So what would you choose? After a little bit of playing around, because you can pair them up in all these different ways. Okay? I'm going to divide every term by sine A, sine B. Okay? There's four terms there. If I divide everything, then I haven't really changed anything. Yeah? So on the top, I'm going to have sine A cos B on sine A, sine B. Okay, you can see there's going to be some cancelling happening here, right? In the same way, I'll take this term and divide it through sine A, sine B.
Should we divide by cos A?
Oh yeah, that's exactly right, actually. I've got it in reverse.
That's right.
Let's try that again.
Right. Well, you're like a genius.
Hey Danny, show me my face.
By the way, since you got your fractions on fractions here, right, might help you just to make it a little clearer so you don't get confused where your fraction starts and where it ends. This term here, you can see is going to cancel completely, right? Yeah. And this one on the end, you're going to end up with a product. How does it work out? Okay, you got your cos B's over here, cancel. You've got your cos A's over here that cancel. This whole thing cancels and ends up being just 1, right? And what are you left with here? That's tan A, sine on cos. This is tan B, sine on cos. And this is tan A and tan B, because both of them stick around, right? So I've got tan A at the front, tan B in the back, and then 1 minus tan A, tan B on the bottom. Okay? Now, in exactly the same way, and I'll let you have a go at it yourself, as we did here with the odd and even function business, right? Tan is an odd function. Tan's an odd function. Okay, and you can remember that just by looking at it. Looks like this. Clearly not even, right? But it's got the same kind of symmetry as sine. So therefore, when I switch out, which color do I want? When I switch out the A's for, the B's for negative B's, right? What effect will that have on this? What's going to switch? Which signs will switch? Okay. So, I'll let you have a go at that in a second. And then I'll write it up for you. That's the spirit. Okay, so did you get there? So like I said, tan is an odd function. Okay, so if you want to be cheap, you want to save some working. Even though it's wrong color, it's a bit dangerous to do this with trig functions because usually, if I had a 2 here, I couldn't simply put the 2 out the front. But because it's an odd function, that negative sign can just go out the front. Okay, and the same thing here. That negative will cancel with this and make a positive. Okay, therefore, just like I did with sine and cos, if I want to put both of these expansions, the sum and the difference together, I could write it like this: tan A plus or minus B. What would it look like? Well, you're going to have plus or minus, tan A, on the top. Because can you see, this sign matches this sign, right? So plus or minus matches up with plus or minus. On the bottom, I'm going to have the thing I had with cos, right? Because this negative makes this positive. And if this was positive, like we had before, it'd make this negative. So I'm going to have both. Here's a,
Negative sign.
not plus or minus, it's minus or plus. Tan A, tan B. Okay. Now, just before we leave off results and have a look at some of the kinds of questions that you can look at with this, we'll generate what we call the double angle results. Okay. So double angle means instead of having A and B, which are 2 different angles, okay, what if I have, well, let's call it 2A. So A plus A. Okay. So it's the same expansion as before, but instead of sine A cos B, there's no B, right? The B is another A. Okay. So you'll get sine A cos A, right? Because I would have had a B there, and then you get plus another sine A cos A, right? So 1 plus 1 is 2. So there's the double angle result for sine. Okay. What happens with cos? Okay. Usually we have cos A cos B, cos A cos B, but there's no B. It's another A. So it'll be cos A cos A. When you got cos times itself, we say cos squared, right? And then you would have had minus sine A sine B. But there's no B. It's still the same as before. It's another A, right? So it's going to be sine A sine A. Okay? Now, cos squared A minus sine squared A. So this is very similar to the Pythagorean identity. Cos squared plus sine squared equals 1. So don't get them confused. Occasionally, because you can use that Pythagorean identity and switch out, say, a cos squared, I can write that as 1 minus sine squared. Okay, have you seen that before, right? So therefore, just gathering my like terms, I could say that. Okay. Or with the same logic, I could get rid of the sine squared, and I could make this 1 minus cos squared over on this side. Okay. So therefore, instead of 1 minus 2 sine squared, I've got cos squared minus 1 minus cos squared. Okay. So the double negative will combine and you get this. Okay, so all 3 of these are fine. They're all legitimate. Okay, they're just different ways of saying this depending on what kind of information you've got, or if you've got a trig identity, depending on which one of these everything looks more like. All right. Okay, sine, cos, one more double angle result. It's on the board, so you guys could tell me this one, right? What's on the top? 2 tan A, because tan A plus tan A. And on the bottom, it'll be 1 minus, and instead of tan A, tan B, they're both the same, right? So tan squared A. Okay? Does anyone have any questions about any of those results? By the way,